Up until this video, we've seen that if you want to differentiate the sum of two parts, so here you want to differentiate the sum of two parts, then you would just differentiate u and then differentiate v and then add the two together. But when it comes to the product, it's so much more complicated. You've got to keep u the same, differentiate the v, and then keep v the same, and then differentiate the u. Why is it that this is so much more simpler than this? Why is it that when you try to differentiate the sum of two parts, it's so much more simpler than differentiating the product of two parts? In this video, we're going to try to understand why this is so much more complicated than this. Okay, so if you look at the two graphs and compare the two graphs, so here you've got the sum of one part. You've got the sum of two parts here. With this graph here, you've got the sum of two parts. With this graph here, you've got the product of two parts. Now, ultimately, if you want to work out the gradient, you need to know this height here. You need to know this height here. We're going to call this height delta y. Delta means a small change in, and then a small change in the y direction in our case. So delta y represents this height here, because, well, we ultimately want to find out the gradient. To find out the gradient, you need to know this height. Okay, and by the way, this distance is sometimes called delta x. We've been using h to represent this length here. So really, delta x in our case it is the same as h. Okay, but the important part is this height here is called delta y because it's a small change in y. Okay, it's just a notation. Now, if you look at the key to understanding why this is so much more complicated than this is in trying to understand why this delta y is so much more complicated than this delta y. You see, when you add the two parts, delta y is really simple, but when it comes to multiplying two parts, delta y becomes a lot more complicated, and here's why. Okay, look at this graph here. Now, if you try, well, if you look at this line here, this line here is the sum of two parts. So if you try to try and visualize it like this, so here you've got your u of x, and here you've got your u of x plus h. So from here to here is just your u of x. It's just your u of x, and then the whole thing here, the whole height here is u of x plus h, and the same with this height here is your normal v of x, and this whole height here is your v or v of x plus h. Now, bear in mind that these two don't always have to be the same height, because if you look at this, let's say for example 3x squared and 4x, you see, if you add a small h into here, this doesn't necessarily have to be the same height as this one here. They could be different depending on the function, depending on what's acting on the x. So my point is that if you look at this graph here, remember that this line here is u of x plus, well, it's the sum of two parts. Okay, this line here is a sum of two parts. So here, so this is your u of x plus h, this is your v of x plus h. So when you have the sum of the two, you can just add them on top of each other. So here, from here to here is us. It is this part here, and then because we're getting one part added to another part, we can just stack them on top of each other. Okay, so now I'm just rearranging it. I'm just going to move this one down to here, so it looks like this. So this is your dy, if you like. This is your dy. So if you look at this here, when you want to find out this height here, you would work out x plus h, and then of the combination of the two. So x plus h, or the combination of the two, takes you from from here to here, and then you would take away your you see this bit here is your u of x plus v of x here. That's this bit here. So this bit here is your delta y. So this bit here, so delta y is really this bit here. Delta y is this bit here. So basically you would work out your whole height here and then take away your normal u of x plus v of x here. So basically looking at this diagram here, this is your delta y. This is your change in y. Okay, so when you add the two, it's nice and simple. When you add the two, it's nice and simple. It's just simply this bit here. Okay, this is your delta y. Now now looking at the product of the two, now looking at this this graph here. Now when it comes to the product of the two, it becomes quite complicated, because if you have bear in mind that this graph here is the product of the two is this thing multiplied with this thing. Now if you want to find out delta y here, if you want to find out this height here, you got to visualize it like this. So normally your v of x is like this. Okay, so your u of x is here, and then this whole thing here is your u of x plus h. Now you see, if you look at this bit here, if you want to jump from here to here, then you would get your x plus h and put it into the u. So that will give you this whole length here. Okay, and then you also have to put x plus h into the v here. That will give you this length here. Now because the graph here is saying multiply the two together. The graph is saying multiply the two together. So from here to here, from there to there would represent the area of the whole thing here, because you've got this thing multiplying with this thing here. So this height here, the total height here, from here to here, that total height there is really the total area of this whole thing here. Okay, and then if you want to take away this height here, or this height here, just simply you putting it into the u, simply you putting it into the v, multiply the two together. You see this height here is represented by this purple area here. This purple area here, and then this height here represents the whole area here, or the whole lot here. So if you want to work out dy here, which you ultimately do need to work out this height here in order to work out the gradient. But remember, we are just trying to understand why this is so much more complicated than u of x plus v of x. Well, the reason why it's so much more complicated is that dy here, dy is represented by this area, the red area here, and this one here. So you've got to add the two. Yeah. So the reason why it's so complicated is because dy in this case here, because you're multiplying the two, dy is represented by this whole thing here. Up here, when you look at this graph here, you're just adding the two. Well, when you add the two, it's nice and simple. When you add the two, it's just you getting this, and stack it on top of this one. So it looks like this, and then you can rearrange it. So it's really, well, dy is nice and simple. Okay, dy here is nice and simple. But when you come to multiply the two, dy becomes this whole area here. Okay, the moral of this video is that just understand that this is a lot more complicated than this here. Okay, well, yeah, differentiating the product of the two parts here is a lot more complicated than differentiating the sum of two parts. Just bear that in mind, and the reason why is because when you try and understand this here, dy for the product of the two represents this whole thing here. It's a lot more complicated. Okay, just there's nothing more to understand. Just understand that this is a lot more complicated than this here. Okay, just that's all you need to understand. Understand that this is more complicated than this. Okay.